Hello friends, I am Viomesh Singh from GeeksforGeeks and I am your mentor for operating system. In this video, we are going to solve some GATE previous year questions based on Semaphore. So this is the next question. You can see this was the length of the question. So that's why I have told you the question is scary. But let's solve it and you will find it very easy. So what is the question? First read the question. We want to synchronize two process P and Q using binary semaphore S and T. So there are two semaphores S and T. So let me write semaphore S and T. And the code for the process P and Q is shown below. So this is W and X and Y and Z. We don't know what it is, but process P is printing 00 and process Q is printing 11. So that's definitely true. After that, let's read remaining part of the question. Synchronization statement can be inserted only at point W, X, Y, G. That means wait and signal operation can be performed only at the point W, X, Y, Z. So W, X, Y, Z are used for wait or signal. Fine. Which of the following will ensure the output string will never contains a substring of 0, 1 की power n or 1 की power 0n where n is odd. So what is it? Ask 0, 1 power n 0 or 1, 0 power n 1 and n is where n is odd. Fine. So this should not be the case. Fine. This should not be the case. So how it will be printed? If process P is performing task and after that process Q perform task, that means there will be double zero. Fine. And after that there will be double one. So that's it is pretty simple. That's it looking very straightforward. If suppose process Q is performing first, so double one will be printed first, and after that process P implemented, that means double zero will be printed. So it is looking very fine right now. That means this should not be the case. But what will happen once process P or Q are context switch or preempted in between? That means if process P is preempted here and process Q is preempted here in these two lines, then we can get this situation. Fine. So how can we ignore this situation? So initially, first of all, we don't know the value of S and T. So you can see S and T are initially 1, S and T are initially 1, S and T are initially 1, or S is initially 1. In C option, there is no, there is T semaphore is not utilized. T semaphore is not utilized in C. So initially we are taking S and T both 1. So suppose S is also 1 and T is also 1. Fine. So if both are 1 and we know to implement the critical section, first operation should be wait operation. So W and Y are presenting wait operation only. So you can see either A, B, C. These can be true. V cannot be true. So this is the incorrect. We already eliminated this answer. And now among A, B, C, we are checking only A and B because there only S and T value is 1. And we can see the Y. What is Y? P, P, and P. So in A and B, both are decrementing the semaphore T. So that's also fine. Now let's see, suppose process P is performed. So what will happen? It will perform first W line. That means value of the semaphore goes from 1 to 0 from A and B options. Fine. And after that, it is printing 00. So suppose 0 is printed. As I have already told you, the problem comes once process P or process Q can be printed while printing. They cannot print together 00. So that's why suppose it is printed here. So it is printed or context switch and process Q comes, and what will it do? It will perform the line Y. So once it is performing line Y, that means it is decrementing the P of T. So it is decrementing the P of T. So if P of T is going to 0, with the option A. We are checking option A. Fine. So if semaphore was 1, semaphore value of t was 1, so it can successfully go inside its critical section. That means it is going to print 1. So after printing just 1, suppose it is again printed and process B get the CPU again. So answer will be 0 1 0, and now it is odd because in very simple string, if n should not be the odd, fine. Here n is odd. So if value of what is the minimum odd number is 1. So we got the 0 1 0. So answer A cannot be correct. Fine. And let me tell you, we need not to solve everything. Why? Because we have seen we can get 0 1 0 or 1 0 1 only once when both semaphore are 1, then only both can go inside their critical section. Fine. If S and T, if value of S is 1 and T is 1, both are 1, then only they can go inside their critical section. Fine. So what will happen if any one of them is 0 or only one of them is 1? Fine. So let's directly jump into the C option. Option C is utilizing only one semaphore S. It is not utilizing the T semaphore. So let's remove it. It is not utilized here. And what is the value of semaphore S in initially? Semaphore S is initially 1. So let me write initially 1. So in W, you can see P of S operation. That means semaphore value goes to 0 by when process P want to write, it will perform the W, that means P of S. So P of S is decremented to 0. After that, it is printing 0. Now suppose it is printed. Now suppose it is printed. Here you can see P of at Y, P of S is also performed. So Q will also perform Y instruction where Y is P of S. But here P of S is unsuccessful operation because semaphore is already 0 and it is binary semaphore. So it will go into the blocked state. So process P can be preempted, but 0 0 will be printed continuously. You cannot print in between. Fine. So if we are utilizing only one semaphore S, where or you can either use T, but it should be only one semaphore. In that case, only one process can go inside their critical section, and in that case, this two condition can never occur because I have already told you to get 0 and 1 continuously. That means 0 1, where n is odd, they should be printed in between. Fine. They should be printed in between. Suppose it is not printed in between. Fine. Suppose, let's see another condition 0 0 1 power n 0 0. Fine. So that can be also the case. P already performed the 0 0. Then Q is performing printing 1 ki power n, and it is odd. That means it should be printed sometime after printing 1, either just by printing just 1 or either printing 1 3 times. That means once it performed total Q operation and it is again try to implement the same section of code to print, and in between it can be printed. So you can see printing is necessary in between these two lines, in between printing. That means this can be occur only when S and T both semaphore are 1. So option A, B, and D are automatically eliminated. Fine. I have solved uh, A options as well as C option. We have already eliminated option D directly because it is not performing V, it is performing V operation initially to access the critical section. That is not true. That cannot be true. So in if you know the semaphore by heart, you can solve this directly because you know there must be a preemption to get the odd number of 1 or odd number of 0, and for the preemption semaphore S and T both must be 1, then only there can be odd number of 1 or 0. So guys, I hope you understood this question. Okay guys, let's discuss very tricky question because it is based on Semaphore as well as Deadlock. And it was asked in GATE 2013. If you know the concept of deadlock, then only solve this question. If not, then first study the deadlock. First watch the videos of the deadlock, or at least have some basic idea what is deadlock. Then only solve it. So let me read the question. There are three concurrent process XYZ or XYZ execute three different code segments that access update the certain shared variable. That means they are want to access critical section. Process X execute B operation on semaphore ABC. So for process X, there are three semaphores ABC. That's fine. For process Y, there are it also perform the P operation on the semaphore B, C, D. So semaphore are different. Some semaphore are shared, but some are different. You can see for X semaphore are ABC. For process Y, semaphore are BCD. That means BC are shared between process X and Y. And now process Z execute P operation on the semaphore CDA. That means process Z is sharing semaphore D with the process Y, and it is sharing semaphore A with process X. That so before entering their respective code segment or critical section. So we know they can perform the critical section by only performing P operation or wait operation on their semaphore. And after completing the execution of the code, they need to perform the B operation. We also know that. But what is the question? Let's read it. All semaphores are binary semaphores. That means value can be either 1 or 0 and initialized to 1. That means all semaphores are 1. Fine. Which one of the following is the deadlock free? Deadlock free. First of all, what is deadlock? Suppose there are two processes, P and Q. There are two processes, P and Q. Suppose P want two resources, R1 and R2. And P1 gets the resource R1 and Q also want process and so first of all, let's see what is deadlock. Suppose process P want two resources R1 and R2 and process Q also want resources R1 and R2. So there are two resources R1 and R2. Fine. And P request for R1 and R2 and Q also request for R1 and R2. Suppose P1 get the resource R1 and Q process Q get the resource R2. Now, to complete its operation, P also need R2, but R2 is occupied by the Q, and to complete operation, Q also need resource R1, but it is occupied by P, and both are not leaving their resources. Fine. So that is the deadlock because they cannot complete their task. Both have occupied something which is required by some process else or someone else to complete their task. So this is the deadlock. I hope you understood. If you understood what is deadlock here, then only you can solve this question. So we want deadlock free. So this is the main condition here. So these four options was given. So let's solve on W on X. For X, what are the semaphore? So for X, there are three semaphore A, B, C. So P of A, P of B, and P of C. So let me write A, B, and C. For Y, there are three semaphores. So let me write B, C, D. So B, C, D. And for process Z, there are three semaphores C, D, A, and it is given before entering their respective code. Let me see what is the initial value. Okay. Okay. Here you can see all the semaphores are binary semaphore and initialized to 1. So let me write A equal to 1, B equal to 1, C equal to 1, D equal to 1, and A, B, C, B, C, D, C, D, E. So there are only 4 semaphores. Fine. So let's start. When can we get the deadlock, first of all? So suppose there are two processes, P and Q. Fine. And they want to exit their critical section. If they are using the same semaphore, fine. Suppose they are utilizing the semaphore S. So P of S, that means wait operation on the semaphore, and it is accessing the critical section. At that time, if Q want to perform the P operation on the semaphore S, it cannot be performed because semaphore S value is already changed from 1 to 0. So it cannot go inside their critical section. But, but let me tell you another condition. Suppose it is accessing another semaphore. It is accessing P operation on another semaphore T. So it can access its critical section. That's fine. Both have entered their critical section. Both will complete the task, or even though it can be affected by each other, but it is not a deadlock. Now, what could be the case for the deadlock? So suppose there are to enter their critical section, they need to perform two wait operations. S and T both are 1. Fine. And to enter their critical section, first it need to perform uh, wait operation on S semaphore, then it need to perform S operation on T semaphore. Then only it can execute its critical section. And suppose Q also want to access their critical section, and it can access by this only. So suppose process P is implemented first, so it will execute this line P of S. So S value goes to 0. And after that, it is preempted. After that, it is preempted here. So for preemption, I am using a star. So it is preempted and Q get the CPU. Now Q want to access the semaphore S, and it want to perform the wait operation of P operation, but it will not be successful because semaphore value is already 0. And after a certain period of time, Q will leave the CPU and process P will get the CPU, and it will perform the next instruction, which is P of T. So P of T is from 1 to 0, and it will access its critical section. And after that, it will perform the B of T and B of S, and then Q can access the critical section. So that seems fine. There is no deadlock right now. Fine. Now let me tell you where can we get the deadlock. So suppose order is changed. Order is changed now. Fine. And initial value of both semaphore are 1. Initial value of both semaphore 1. Fine. So suppose P get the CPU first, it will perform the first line P of S. So value of S goes to 0. Fine. And after that, it is preempted. For preemption, I am using star, so it is preempted here. And Q get the CPU. Q will perform the P of T. So value of this is 0. So these two lines are executed successfully. After that, Q want to execute next line, which is P of S, which is P of S. But P of S will not be successfully implemented because semaphore S is already 0. Are you understood my point? Because in binary semaphore, if if the semaphore value is 0, then process will go into the blocked state. Fine. So process Q cannot complete, or process Q cannot enter in its critical section. Now suppose process Q is preempted, and process P get the CPU again. Process P get the CPU again, and now it want to execute next instruction P of T. Now P of T cannot be implemented because semaphore T is already 0. The value of the semaphore T is 0. So it cannot be implemented. So process P and process Q both is stuck. Both have implemented one wait operation, and they are waiting to implement another wait operation to enter their critical section, but they cannot perform. So for deadlock, if order is changed, then only there can be deadlock. If order is same, then there cannot be deadlock. So from this, I have draw a conclusion. Order matters. Order of semaphore execution is matters, or order of wait operation on semaphore is matter. Fine. If order is same, then there will not be deadlock. If order is changed, order is different, then only there will be a deadlock. So let's start with the first instruction, first option A. If we talk about A option in process X, A, B, C, that seems fine. In Y, B, C, D. So B, C is common between process X and Y and they are in the same order. That's fine. In process Z, sequence is C, D, A. So you can see between Z and Y, C, D is same. C, D are shared and they are in the same order. That's also fine. But in Z and X, in between process Z and X, order of A and C is different because in process X it is AC and in process Z it is CA. So let me solve option A here. So here you can see sequence BC is same in process X and Y, and in process X and Z of C and D sequence is same. But in process X and Z, A sequence is AC, but here sequence is CA. So suppose they so X and Z, suppose X performed P of A first, and after that it is preempted, and in the meantime process Z perform P of C first, and after that it want to execute P of D, it is implemented successfully. Now it want to implement P of A. It cannot be implemented because P of A is already performed. That means semaphore value of A is 0. And suppose Z is preempted because it is blocked here. It is incorrect. It is blocked because it is was not executed and X get the CPU again. So it will perform the P of B successfully, but once it try to perform the P of C operation or decrement the semaphore C, it won't be successful. Why? Because P of C is already performed by process Z. So that cannot be done. Fine. So here we got the deadlock. Let's check second option. Now we need to see, we can directly see the sequence BAC, X is checking BAC, that's fine. BCD, so B and C sequence is same, A is in between. Then ACD, so sequence is P of B, P of A, and P of C. Here P of B, P of C. So we can see the sequence BC is common here. So BC sequence is here. Uh, First B, then C here. BC sequence is good. Here common variable are C and D. So CD is here, fine. CD is here. But what about AC? Here AC and here is also AC. So order seems fine. Order seems fine here. So answer should be B. Let's check other option as well. We have seen option B is correct. If you want, we can check another option as well. So I am taking only one option, C. I won't take D. If you want, you can check by your own. So in C, you can see what are the sequence P of B, then P of A, then P of C. And in Y, the order is P of C and P of B. So order is changed. You can see in X, B performed first, wait operation on B performed first, then wait operation performed C. But in Y, B or wait operation performed on C first, then it is performed on B. So order is changed. So C cannot be correct. C is incorrect answer. C will provide the deadlock. And let's check last one. So in last one also, in last D option also, order is change. Order is reverse. So here it is BC, here it is CP. So option D cannot be correct. Option C cannot be correct. But option B can be correct because here you can see the sequence BAC. So BAC is fine. Here BC, common is BC. So it in X, in process X is what it was BC, and in process Y it is BC. That's fine. And in process Z it is ACD. So if we see CD in Y and Z, CD is in same sequence, and in Z and X, A and C are in the same sequence. So B is the correct answer. So only option B is correct. It was it was very tricky question, and but if you understood the deadlock, if you know the deadlock, it was very simple because you just need to see the sequence. Fine. In shared semaphore, sequence should be same. If sequence is same, then only it will be deadlock free. So you just need to see the sequence ABC, BCD, and CDE. So you are just checking the sequence. If sequence is same, then you can get the answer. And to check the sequence, it hardly take 2 minutes. And in gate there is 2 minutes for every question. It is lengthy question to read. It takes time to read this question only. And after that, if you know the concept, you can solve it within 2 minutes. Okay, guys, let's solve next question, which was asked in GATE 2003. What is the question? A shared variable x. So variable is small x because there is another process with capital X initialized to 0. So x is 0 and is operated by four concurrent process W, X, Y, Z as follows. W and X reach the memory. This is the first instruction. Then increment by 1. So this is the second instruction of WX. Then stores it to the memory, or we can say variable. Fine. So it is the three-step process, or there are three instructions in this process W and X. And what are they are performing? They are performing increment by 1 operation. And each process Y and Z, Y and Z. Now we are talking about the Y and Z. Reach X from the memory. So this is the first instruction. Then decrement by 2. It is decrementing. This is the second instruction, and then store it to the memory. So this is the third instruction, and then terminates. That perfectly fine. Each process before reading X invokes P operation. We know P operation is the wait operation on counting semaphore. We are not utilizing here binary semaphore. In question, it is given counting semaphore. That means uh, more than one process can access, depend on the value of the semaphore. So V is the signal operation, we know that. And after storing the X, process perform the V operation. That's fine. Now you can see semaphore S is initialized to 2. That means if you know the counting semaphore, you know the value of the initial value of the semaphore tells us how many process can access their critical section simultaneously. Fine. So value of S is 2 now. Let me write value of S is 2. And in question, it is asking what is the maximum possible value of X. What is the maximum possible value of X after complete execution? That means we need to execute all process W, X, Y, Z. So Let's write all three instructions of each process. So I am using microprocessor instruction. You know already because we have utilized that. So here you can see W operation and X operation, what they are doing, they are first reading from memory. That means variable value of the variable is stored in the register, so it is reading, and after that register value is incrementing, and after that value of the register is stored in the X. So this is W and X, and here you can see Y and Z. They are first reading, so I am using load value, and after that it is decrementing by 2, so r equal to r minus 2, and then stored to the memory, or we can say stored to the variable x and r. And now to perform this operation they need to perform p of s and v of s. So this is the wait and signal. So let me write it. So here you might think what could be the maximum value. Suppose W has been performed first. If W has been performed first, so value is incremented, value of X will be incremented by 1. Then X is implemented, then value will be plus 1 again. That means it is 2. And after that Y and Z, so it will decrement by a value by minus 2, so it is again 0. Then it is decremented by 2 again, so it is again 0. Fine. So it is minus 2, not 0. So value is minus 2 we are getting after all process complete execution. That means we need to complete the execution as well. So you might be thinking that answer should be minus 2, but it is not, because they are not using binary semaphore, they are using counting semaphore. That is the beauty of this question. That is the beauty of this question. So let's solve this question. So let's solve this question. To solve this, I need some space. So I am removing the question statement. I hope you already know the statement. So suppose first W want to be implemented. So W will perform the P of S. So P of S is performed. So value of 2 goes to 1. Fine. And then it is reading the value, and it will increment the value r equal to r plus 1. So r equal to 0, and then r equal to r plus 1, that is 1. And before storing the value, it is printed. So before storing the value, it is printed. Now suppose process y comes, and semaphore value is 1 now. So it will perform the P of S successfully because value is 1, so it goes to 0. That's fine. And now it will read the value of x. So value of x is right now 0 only. So it will take value r to 0. So let me write r of w here, and here r of y. So r of y is 0, and r of y will decrement its value. So 0 minus 2 is minus 2, and then it will store the value. So x is minus 2. So value of x goes to minus 2. And after that, it will perform the V of S. So value of semaphore S goes to 1. Now process Z comes into the picture. And process Z will execute P of S first. So that's fine. So value, it will be executed successfully because SEMA in critical section, there can be two process can exist simultaneously, because P that will execute P of S successfully because two process can be in their critical section simultaneously, because initial value of semaphore was 2. So it goes to 0. So it will read the x now minus 2. So value of rz is minus 2 here. And here you can see it will decrement the value. It will decrement the value by -2. So R of Z will go to -4. And after that, it will execute next instruction, store X to R. So value of X is -4. So value of X is J to -4. And it complete its execution by performing P of S operation. Now semaphore goes to 1. Fine. Semaphore goes to 1. After completion of Z, suppose process W get the CPU back, and now it will perform the remaining instruction. What is the remaining instruction? X equal to RW. So what is the value of RW? 1. It won't read or it won't implement the previous instruction because of the concept of context switching. So value will be directly changed from -4 to 1 because more than one process are accessing their critical section simultaneously. That's why I've told you the the question setter or the person who's uh, prepared this question was very intelligent or very clever, because instead of initializing semaphore to 1, he initialized the semaphore to 2. So because of race condition, W will implemented and it will directly change the value to 1. And after the W, suppose process X will get the CPU, and now what X will do, but before X will get the CPU, W will perform the V of S operation. So value of semaphore goes to 2 now. Now process X will get the CPU and it will perform the P of S. So P of S goes to 2 to 1. Then it will read the X value. What is the value is 1. So register get the 1. Then it will increment the value R equal to R plus 1. So value will be 2. You can see process W and X are incrementing the value. After that, it will store the value. So R of X, R of X, R of X. So value of X will goes to the 2. Fine. And after that, it will signal the semaphore. So all processes are completed and maximum answer we got 2. You might have thought that answer could be 0, -2, -1, maybe anything. But the person who prepared this question was very intelligent. He initialized the value of the semaphore 2. If you are able to solve this question, trust me, you can solve 99% of semaphore based question. You will able to solve any question in the GATE exam. I hope you understood this question. If not, please provide the feedback. But before providing the feedback, please watch this answer or watch this solution again. And one more thing I want to tell you, if you are liking this video, if you understood the concept, because we are working hard to teach you. If you liking this video, please provide the positive feedback as well. Feedback is not only for the doubt. It You can also use your feedback to motivate us. Thank you guys. Hello guys, let's solve the 2010 question. The following program consists three concurrent process and three binary semaphores. And semaphores are S0, S1 and S2. Only S0 is initialized to 1, S1 and S2 are 0. And this is the program. So process P0 is printing 0 apart from waiting and signaling, while process P1 and P2 are just waiting and signaling. Fine. In question, it has been asked how many times will process P0 print 0. So let's start. First of all, which process can be executed? Only semaphore S0 is 1, and S0 and wait operation on S0 is performed by P0 only. So P0 can be performed first. So suppose P0 is performed. So how it is performed? First, it will execute line wait of S0. So that is from 1 to 0. After that, it is printing 0. So 0 is printed. Fine. After that, it is releasing S1 and S2. That means value of S1 and S2 goes to 1 and 1. And so P1, now P1, suppose P1 get the CPU or P2 get the CPU, it does not matter. So let me write the post sequence. Suppose after P naught, here P1 get the CPU. So P1 will lead the S naught. So value of S naught will goes to 1. And after that, P2 will get the CPU and it will release S naught. That means it will change the value or it will modify the value of semaphore S naught to 1. So it will override the value 1 to 1. So P2 is performed. And after that, you can see while true. So P naught will get the CPU again and it will print 0 and it will release the value, release the semaphore S1 and S2. Same will be happen if we change the sequence. Suppose after P naught, first P2 will be performed, then P1 and then P naught. So 2 0 are printed here. So some of you might be thinking that answer should be exactly twice, but there is another sequence as well. Or some of you might have just executed till P naught, P1, P2, and they might be thinking answer is exactly once. That is also incorrect. Let's solve another sequence. Initially, P naught can be implemented. So weight of S naught, that means value goes from 1 to 0. And after that, it is printing 0, so 0 is printed. And after that, release S1 and S2. So value of S1 is 1 and value of S2 is also 1. Now suppose P1 get the CPU first. If P1 get the CPU, it will decrement the value of S1, so S1 goes to 0 and it will release the S0. So S0 is 1 now. So P1 is performed as S0 is 1 as well as S2 is 1. So process P0 can be performed as well and P2 can. So process P0 and P2 both can execute. In previous example, we have executed P2, but now I'm going to execute P0 again. So in the P0, what will it does? It will weight the semaphore as not. So semaphore value goes to 0, as not goes to 0, and it will print 0. So 0 is printed, and it will delete S1. So S1 is value is 1 now, and after that it will delete S2. That means value of S2 is modified to 1 again. Fine. So after P0, suppose P2 get the CPU. So once P2 get the CPU, it will release S0. First, it will decrement the value of S2, so S2 is decremented. And after that, it will release S0. So S0 is 1. So S0 is 1. That means P0 get the CPU again. So P0 can be executed. Even P1 can be executed, but P0 get the CPU support. So P0 can be executed, and in that case, it will perform the wait S0. So S0 is again 0. So let me draw the uh, line here. So 0 is printed again. Fine. So answer should be at least twice because here we can see more than 2 times P0 printed 0. Fine. But in previous example, in previously, we have seen if we are following the sequence like P0, P1, P2, and P0, or we are following the sequence P0, P2, P1, and P0. In that case, we got 00, and in this case, we are getting 3 times 0. So answer should be at least twice. I hope you understood it. If yes, please provide us positive feedback. If not, please watch the video again. And if you are facing any difficulty, you can provide your feedback and you can ask your query as well. This question was asked in GATE 2014 and it is producer consumer based question and it also utilizing semaphore. That means it is trying to solve producer consumer problem with the help of semaphore. If code was not visible to you, you can see this was the last braces here. So now let's start. Let me read the question first for you. Consider the procedure below for the producer consumer problem which uses semaphores. Fine. So what is the question? Let's analyze the code first. Void producer, that means the code for the producer. While true, that means whenever producer want to produce something, it will produce. It will same weight. So that it means instead of using weight operation, they are using same weight operation. That means it is waiting, just waiting, and it is performing weight operation on S. Fine, semaphore S, and semaphore S is initialized to 1. It is given in the question, and semaphore N is initialized to 0. Fine. So it will first decrement the semaphore S. That's fine. After that, it will add to the buffer. So let me create buffer here. So this is the buffer, and then semaphore signal N. That means it will signal the N and signal the S. If that means if it is signaling the S, what that means, the producer can produce next item, because from 0 to 1 it converted the value from 0 to 1, and if it is converting semaphore N, that means it is allowing consumer to start consuming the product, because initially semaphore N is 0, and that means consumer cannot do anything, because if N is 0, it cannot do anything, it cannot consume anything. Now in the consumer, it is also performing wait operation on the semaphore S, then it is performing the wait operation on semaphore N. So So let's see the question first. What are the options first? So in the question, it was asked which one of the following is true. The producer will be able to add an item to buffer, but consumer can never consume it. The consumer will remove no more than one item from the buffer. Deadlock occurs, and the starving value of the semaphore N must be 1 and not 0 for the deadlock free operation. So let's see what happens. So we should analyze the code. We have already analyzed the code. The code is working, seems fine, but which option can be correct? So let's execute it with one example. Suppose producer want to produce something. So what will it do? It will produce one item, fine, and after that it is decrementing the semaphore S. So semaphore S is decremented to 0, and it is adding the product in buffer. So let me write product for product. I am writing PR1. So PR1 product 1 is added to the buffer. After that, it is signaling the S. So signal is S now, and after that, signal N. So signal N means semaphore N is also 1. Suppose it want to add new item. It want to add new item. What will happen? It will again produce new item, semaphore S. So semaphore S goes to 0 again. After that, add to the buffer. So next product PR2 is added to the buffer. Then signal S. So semaphore S goes to 1, and signal N. So it goes to 2. It was not given that N is the binary semaphore or counting semaphore. But if we are producing again and again, I feel it could be the counting semaphore. So fine. So we are utilizing it as a counting semaphore. So two items was produced. Now suppose consumer want to consume. So to check if consumer can consume the item or not. So first it will check semaphore S. So semaphore S is 1 now. So it will make it 0. Fine. Then it will semaphore wait N. So N is now 1. After that it will remove item from the buffer. Suppose it is removing first item, and after that semaphore signal S. So signal 1. Now suppose it again want to consume item, it will perform semaphore wait S operation, then fine. So S it goes to 0. Then semaphore N is going to wait, so it is 0. Fine. Then remove the buffer. So product 2 is also removed. Then signal S. So S goes to 1, and it performed perfectly. That means first is incorrect. Consumer can never consume item, it's incorrect. Or their consumer will remove no more than one item. We have seen consumer can consume both of the items. So this is also incorrect. Fine. So two items are incorrect, two options. Now we need to check deadlock. We need to check deadlock because option C and option D are talking about the deadlock. Suppose there is no item right now. Fine, because PR1 and PR2 both are consumed. Or suppose initially there is no items. Some you PR1 and PR2 consumed or suppose we are in the initial condition. In both case, if items are consumed, in that case, n would be 0 and semaphore s will be 1. Suppose before producing any item, consumer want to consume one item. Fine. The item are not even created yet. Fine. So what will happen? It should not be happen first of all. Without producing any item, consumer should not consume any item, or consumer should not try to consume. It should not enter its critical section. It should not given any access to buffer. But what will happen if consumer want to consume any item when buffer is empty? What will happen? It will decrement the wait operation. It will decrement the semaphore s. That means it will applying the wait operation on semaphore s. So it goes to 0. And after that, it will try to perform the wait operation on n. But it is already 0. But it is already 0. So that means that means consumer process is blocked here. Consumer process is blocked here. Fine. That means consumer is not going in its critical section. It seems fine. It seems consumer cannot go into critical section. Consumer cannot access its critical section or buffer. That means it should be fine, but it is not. Why? Because consumer is performing wait operation on semaphore s. So consumer is blocked. Consumer is blocked. Consumer cannot do anything. But in the meantime, producer want to produce an item, and consumer can consume only after the producer. So if producer want to produce any item, what will it perform? It will perform the produce function. So it is producing one item. After that, it want to implement this instruction wait s. It want to perform wait operation on semaphore s, but it is already 0 by consumer. So it is also in blocked state, and both process goes into blocked state. That means it is a deadlock. Semaphore consumer cannot consume any item because it is waiting for the signal of n, which can be performed only by the producer, and producer want to uh, perform the wait operation on semaphore s, but a signal can be done only by the consumer. So both are waiting for something which is contained by other process. So that's why it is deadlock. So answer would be C. I hope you understood the answer. If not, please watch the video again. And still you are facing any problem, please provide your feedback. And if you find our explanation good enough, then please provide positive feedback. Let's discuss next question. And what is the question? Consider the following solution. First of all, it looks really scary question, but trust me, semaphore question are very lengthy to read, but there is not much computation to do. That means semaphore questions are based only semaphore questions are only depend on your analysis of the code. So let's see how it will work. Consider the following solution for the producer consumer problem. So again, this is the producer consumer problem. That means critical section problem. Shared buffer size n. So buffer size is n. There are three semaphore empty, full, and mutex are defined with the respective initial value 0 and 1. 0 for empty, n is for full, and 1 is for mutex. That's fine. Semaphore empty denotes the number of available slot in the buffer for the consumer to read. That means the item already filled. Then because consumer can consume the item. Fine. So empty is telling us where consumer can consume the items. That's fine. Semaphore full denotes the number of available slots in the buffer. That means how many items producer can produce, where empty slots is saying how many items consumer can consume. Then after that, the placeholder variable denotes PQRS. There are PQRS, so this is PRQS. There are 4 PQRS in the code below. Can be assigned either empty or full. What the valid semaphore operation are wait and signal. So let's see what can be happen. First of all, according to the question, empty is 0 and it can be accessed only by the consumer. Fine. Full can be accessed only by the producer. And mutex, we can see mutex is accessed by both. So mutex is the semaphore which is accessed by both producer and consumer. So that's fine. Full is telling producer how many available buffer slots. That means how many item it can fill in the buffer. And empty is presenting the information how many item consumer can consume right now. That means how many buffers are already filled. Fine. So let's see what are the options. Options are full, full, empty, empty. So let's see. First of all, to produce any item, first it need to perform wait operation on full. Why full? Because producer, you can see it is written here, semaphore full denote the number of availability. So that means it will decrement the full value which is already, and that means right now n slots are available, but it should be decremented. So first p should be full. So there are two options where p is full, full, a and c. So only these two can be the answer. B and D cannot. Fine. And after producing one item, then only consumer should consume. Fine. If not, suppose it is performing the wait operation on R. Fine. It is performing the wait operation on R. So R should be empty first of all. So here you can see R is empty in both the cases. Fine. So that is also fine. If it is performing the wait operation on full, then there will be a issue because consumer can go inside the critical section before the producer, which should not be the case. So this is correct. In A and C, R should be empty. So that's perfectly fine. But what should be signaled by the producer? Producer should signal the empty. Why? Because it is increasing the value of empty semaphore, which are representing how many items consumer can consume right now. And otherwise, empty will always be zero. Empty is initially zero. So it should be signaled by one, or it should be incremented by some operation. And consumer cannot signal itself initially. So which process can signal the empty? Only producer operation. Fine. So producer operation can signal. So Q should be empty. So answer should be C because P is full, Q is empty, R is empty and full. So let me see if we are using this full, empty, empty and full. So let's see how it works. First of all, it is performing the wait operation on full. So n it goes to n minus 1. That's fine. One item is already filled. Suppose this is the size of the buffer and size is n. So now item 1 is filled here. And so it is, so now remaining space is n minus 1. That's fine. And after that, it is signaling Q. So that means next available uh, product. Where is the product is available at first location? So it should be signaling 1. So it is 1 now, 0 to 1. Fine. After that, consumer can consume the item. Yes, consumer can consume the item. It will decrementing it 0 and it will perform the consuming the item by weight mutex, and after that it will signal the full. That means now producer can produce next item. So that is perfectly fine, even though it seems like a strict alteration method, but it is working fine. There is no deadlock and it is working fine. So uh, this was the question, producer consumer problem. I hope you understood the question. Question is seems very lengthy and very scary, but it is not. It's all the problem based on the semaphore are lengthy in gate paper most of the time. But the R to solve semaphore problem is just to analyze the code, just to analyze the question. You need not to solve so many, you need not to perform computation much. Fine. Just you need to analyze the code. So I hope you understood semaphore concept with these many previous year questions. Still you are facing any problem, just feel free to write us. Thank you guys. Thank you very much.